Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year, we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen, you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session, and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Hello and welcome to today's webinar, which is, as you can see on the screen, on how to reduce green hydrogen project costs. Today we'll have two experts who will tell us all about how you can keep the cost of green hydrogen projects low. But before we do that, I'll just have a couple of housekeeping announcements and we'll get started. So to start with, just to let you know that this webinar is being recorded. You will get a message with the recording, and also that you can send questions using the Q&A box. Just a little reminder of those two things. And then actually, before we start with the presentations, I would like to welcome all of you, but also our panelists, and ask them to give a very brief introduction of themselves. Perhaps Lina, if you could start and let us know very briefly who you are.
Thank you, Carlos. Good morning, good afternoon, everyone. My name is Lina Hijazi, and I'm currently taking the role of Senior Director EPCM at Ohmium. And I come from a renewables background, 15 years in technical project development, doing wind, solar, battery storage, microgrids, and the past couple of years also green hydrogen. And my current role is with Ohmium. I've been with them for the past year, a little bit more. Thank you.
Thank you, Lina.
Thank you very much, Lina. Go on, Matthew, please introduce yourself.
Hello, everyone. It's a pleasure to be with you today. My name is Matt Wiils. I'm Kent's Market Director for Low Carbon. So I'm responsible for the molecule side of decarbonisation. That's hydrogen, all different colors, carbon capture and storage, and low carbon fuels and chemicals. I've been with Kent for the best part of 20 years, and looking forward to today. Thank you.
Great. Thank you very much, Matt. So, and now we'll open the floor to Lina so she can start with her presentation. And before you start, Lina, so please start sharing and all of that. But there is one thing I forgot to mention, that is that we encourage all of you to use the chat to introduce yourselves. So please do let us know who you are, and using the chat function, so we can do a little bit of networking, and getting to know each other, even though we are online. So, I could see your presentation, not anymore.
Okay, just 1 second.
Okay. I think if you put it on full screen, it should be good. Perfect. All right. I can see it on full screen. So yeah, over to you.
Good. Okay, so I'll kick this off. So first of all, it's a great pleasure it's an honor actually to represent Ohmium in this webinar, along with one of our very close EPC partner. We worked with Kent on a couple of transactions, a very successful interaction between both parties. And we decided to host this webinar basically because the Ohmium solution is a modular kind of solution, and it facilitates a lot the design and development process, but also a lot of capex savings and optimizations. And we also thought you would hear from the perspective of an EPC contractor how modular systems facilitate the development process and also the construction process. So we'll start off with a quick overview of Ohmium and what is the scope of supply that we provide, and how that contributes to lowering EPC costs, and then moving on to a little bit about the development process and how this can be facilitated. And then you'll hear from my colleague Matt about their experience with modular electrolyzers and their experience in simplifying project development through modularization. Okay, so Ohmium is a manufacturer of PEM electrolyzers and hydrogen solutions. We were established in 2019. We are a US-based company with American IP but leverages on scalable Indian manufacturing. We currently have a factory in India with manufacturing capacity of 2 gigawatts per year. We do not have any restriction on operating on countries where we operate. So we have a global presence with projects worldwide, with a solution that is compatible with all industries, whether it's mobility, refinery, fertilizer, whatever the industry is requiring clean hydrogen. We pride ourselves on our market-leading efficiency of 48 kilowatt hours per kilogram. And this is not stack efficiency. This is overall system efficiency. And our integrated and modular design, it enables a low installation cost solution, and that because that contributes to the optimization of your LCOH targets. On top of that, we have advanced power electronics capabilities with a solution that is capable of being, compliant with stringent grid conditions. So, what does Ohmium provide? Well, in the green hydrogen space, majority of the players they provide the stack, but we actually provide a solution. Starting with so all the elements that you require to produce hydrogen are included in the system that is designed, manufactured, and provided and dispatched by Ohmium. Starting with a water purification system. All the hydrogen stacks and its dryer bays, the cooling system required to regulate the temperature required for electrolysis, the electrical infrastructure starting at low voltage distribution, including the rectifiers, DC to DC converters, telecommunication and PLC, and on top of that, an uninterrupted power supply for the safe shutdown of the solution. So if you go to the engineering, procurement, and construction, so the E&P portion are covered for the electrolysis mostly is covered by Ohmium, but everything that is outside of the battery limits is covered by our EPC partner. And all of those elements that contribute to the electrolysis process, we call them the balance of stacks. So it's a comprehensive balance of stack solution. And then everything is prefabricated in the factory. So when it is dispatched to site, it is, or you just in cabinets, you just place them quickly, and that contributes to improving your installation costs, because you require less people, less skilled people, and because everything is prefabricated and manufactured and pre-assembled in the factory, you don't have to do any of that work on site. You just place the cabinets and connect them with each other, and there you go, you have hydrogen. So let me show you actually how the system looks like. So you see those multiple cabinets, all of that is, we call it a one island solution, which is around 4.2 megawatts. And all of those cabinets that you see, sir, each of them serves a different function. One is a electrical distribution panel to take in low voltage. You have the power cabinets that distribute a DC power to the stacks required for electrolysis. You also have the hydrogen cabinets where you have the stacks, and then you have a telemetry cabinet which has the PLC and the uninterrupted power supply. But what you see here is a facilitated or simplified interface system, where you just input a you give it a low voltage power supply, DI water, and then the output will be hydrogen at 10 bar or 30 bar. And I also failed to mention before the water purification cabinet that has a water treatment system included in it. Which is RO based, and it has filters inside, so you don't need additional water treatment if you have DI water. So why does all of that contribute or gives value to LCOH, or levelized cost of hydrogen? Because starting with AC power in, right, there's a lot of elements that are incorporated into the design, which you don't need to add as part of your balance of plant. Like, for example, you don't require harmonic filters because we have PWM based rectifier. So instead of the thyristor based, so you don't need any additional harmonics, because the harmonic contribution is within the IEC limits. You don't need, for example, additional capacitor banks, because unlike thyristor-based, our power electronics have, an active interface where you can adjust the power factor. From the water side, you don't need an additional water purification system. You don't need to design it because it's already there. And having an OEM incorporate that into its design is beneficial, because the OEM can control the quality and have cost control over its supply chain. And on top of that, you don't need to design a cooling system for electrolysis, because it's already part of that integrated solution. So all of that comes together quite nicely. And in terms of hydrogen, the output hydrogen, the hydrogen that you get at the outlet is actually at 10 bar or 30 bar. So there are two solutions which you can pick from, but you don't need to design an additional mechanical compressor, because the hydrogen is outputted using electromechanical compression within the stacks. So you don't need to install any additional compressors as long as you are fine with 10 or 30 bar solution. And on top of that, finally, the balance of system. We see a lot of solutions requiring nitrogen, for example. The Ohmium solution does not require any nitrogen. We are satisfied with nitrogen bottles during commissioning and during any maintenance, which are portable. And because of that, and this is possible because of the modularity of such a solution. You don't need any complicated HVAC system because it's an outdoor solution. So you don't need to have the stacks operating inside the building. So you don't need to have a building. So that reduces a lot the civil costs as well. So the only thing that is required is a civil slab, foundation slab, simple, very simple, where and you eliminate the need for any building whatsoever. So there is one output manifold from this island that we call it, and because it's a modular system, if you need more capacity, you just add them next to each other and you just replicate it, and you build up your plant. So if you need 100 megawatts, you might need maybe 24 of those. If you need 4 or 5 megawatts, you need one of those. So let's talk about EPC costs a little bit to show you how that looks like, just to give you an idea. Because of all the different optimizations that have been done with in the design that reflects on the balance of plant, it automatically also reflects on the EPC cost, because you don't need a building, you don't need HVAC, it's very easy to install, so you don't need heavy machinery. Everything is pre-assembled in the factory, so you don't need to do any assembly on site or welding or things like that. So if you see here, for a 500 megawatt project in Europe, in Northern Europe, where it's considered the most expensive worldwide, you can achieve an EPC price of 267 euros per kilowatt. And these numbers, they have been verified by our EPC partners, and they have been verified by independent third-party engineering companies. And you have also in Southern Europe, if you want to have a cost comparison between Northern Europe and Southern Europe, so you can achieve around 213 euros in Europe, but in Southern Europe, and in India go down to as low as 73 euros per kilowatt. Now, let me show you how that looks like actually. So this is one of our projects. It's in a steel factory. It's a very compact design. So you see here, as I mentioned, there's a small foundation slab here. And if, yeah, can you see my mouse? Maybe you see here those two pipes that are running in parallel. One is the water inlet pipe from the customer, which the tie-in point is here. So we just connected to it and plugged it into the water cabinet. And then the output hydrogen manifold is here, right? And the tie-in point from the customer is here, and we just tied into that, and that's it. Voila, they have hydrogen in their facility. Over here they have within the factory there's a control room, so we just pull the cables to the control room where there's from the PCs you can just monitor and control the plant. So we spoke about EPC costs, but what about the development process? So the development process is for green hydrogen plants is consistent with large complex, multidisciplinary, high capex projects where the technical solution is not fully defined. You have multiple technologies, PEM, alkaline, solid oxide, and multiple vendor options available. Where also the permitting authorities require an engineered basis. The cost and risk should be reduced before EPC award, and the client actually wants to execute the project on a firm lump sum EPC basis, and that is a requirement to achieve FID. So this is why. So why is green hydrogen part of that complex development process where you need to do like pre-FEED followed by a FEED, and then after that you reach FID? Because these kinds of projects, they have complex interfaces between transformers, compressors, water treatment systems, hydrogen purification, the grid, safety standards. So because of all of those complex interfaces, a lot of engineering has to be done. So an EPC cannot come and give you, cannot do a simple basic engineering and stand behind their price. So, and because there are so many options available in the market, you start off with a pre-FEED where it gives you a certain level of accuracy. And then if the client is okay, happy with the economics, you move on to the FEED stage where you have the full engineering package that is ready to go to the EPC contractor for a firm binding price. Once the EPC comes back after the FEED package has been finalized and the tender package goes to the EPC, then the EPC comes back with a more or less of an accurate estimate or close to accurate estimate that allows the client to go to FID. How long is that process typically? It depends on the complexity of the balance of plant, right? It can take maybe 3 months, 6 months, 1 year, and the costs around the development are extremely high for the engineering. So it can reach up to $2 million as well. So what we have done is we have pre-engineered a solution where you can take it, you can plug and play it wherever you want. The PNIDs are standard. The solution is compatible in any environmental condition, whether it's 50 degrees or minus 45 degrees. The HAZOP study has been done, and it can be replicated in every project, no matter where. The system is easily integrated into brownfield projects. So instead of spending $1-2 million in the worst case on these kinds of studies and waiting 1 or 2 years to go to FID, you can achieve that in a much less cost and much faster. And I think my colleague Matthew will talk more about this in his slides. Thank you so much. Any questions? Feel free, please, to write your questions or reach out. I'll turn it over now to my colleague Matthew.
Thank you, Lina. So if we go on to the next slide, for those of us who don't necessarily know much about Kent, we're over 100 years old. We originate from the Kent family in Ireland, which was a small family electrical and instrumentation business. And that's grown into a global engineering and project services organization. Kent was set up to tackle the electrification of Ireland in a previous energy transformation. So we're well used to changing energy types. I've worked in our projects, consulting and engineering services parts of the business, and we're an industry leader in completion, commissioning, startup, and we actively support the operations, maintenance and decommissioning of our clients' assets. So if we go to the next slide, please. At Kent, we work across the energy spectrum, and we set ourselves up to courageously tackle the greatest challenge of our time, to bring our world the energy it needs in the most responsible way ever imagined. And that's something we as members of Kent have bought into. I started working on low carbon projects in 2008. I set up our low carbon market in 2018. And as Kent, we've delivered on world leading projects such as Boundary Dam 3, high net hydrogen plants, full biorefineries. And in electrolytic hydrogen, we've worked on around 40 green hydrogen projects, totaling over 8 gigawatts, with design and build work underway. So we go on to the next slide. The challenge from our customers is around cost. Early projects in low carbon, including green hydrogen, have been supported mainly by governments. Future projects now need to be much more economic and able to deliver on energy needs, aiming for the most efficient levelized cost of hydrogen. Where we've had that challenge elsewhere in the energy industry, we've gone for modular and standardized approaches. So we see a great advantage in Ohmium's modular building block approach. And having used it successfully around the world to reduce costs of energy projects, we can make price and schedule more predictable using that modular and standardized approach, which helps to reduce HSE and commercial risk. So what we're doing, simply put, by modularization is moving hours from a construction site and moving them to the more controlled works environment. So that's removing hours and thus risk exposure to construction hazards at site to a more controlled environment, and that increases the overall project safety. We move fabrication to that controlled environment, reducing risk to quality, and we allow inspection and test at Ohmium's works to ensure the quality of the equipment being delivered to site. And that makes our life a lot easier. So Ohmium's approach reduces the site team to a bare minimum and the construction site equipment to a bare minimum, and that reduces the cost and risk for overall green hydrogen units, especially in places like the UK and Northern Europe, where we've got quite high construction site costs, quite high labour costs. So we go on to the next slide, please. So the Spartan approach from Ohmium resonated with us without a lot of the offsites that would go into a standard project. It considerably simplifies the process and the plant scope of the project. That approach improves the delivery of the execution phase. It makes a predictable cost and schedule for subsidy-supported projects, which is a key requirement of our clients in trying to get investment for their projects. Another challenge we have on many places that we operate is the availability of skilled personnel. We can see a considerable and growing backlog of infrastructure projects, power projects, conventional projects, as well as low carbon. So it's getting very hard to get hold of the required skilled labour, trades, professions. Ohmium's approach decreases the amount of people we need at site, decreases by the approach the amount of skilled labour we need. So that reduces the risk of resourcing a project and actually gives us better certainty that we can deliver. Skilled contractors like Kent, we're well versed in brownfield projects. So that's being able to deliver the balance of plant around the hydrogen project and to connect into the industrial or energy site that's using that hydrogen. But key in there is keeping people safe. So we've been working with hydrogen safely for over 50 years. We recognize hydrogen as a hazard, and there are differences in the safety risk because we're changing the way in which we use that hydrogen and we produce that hydrogen. So we well understand the risks arising from this type of plant, as well as those around such a plant. So the risks from the existing plant onto the new plant and Ohmium's plant onto the surrounding area. Lina mentioned that we've got a HAZOP already of their system, so that makes our life a lot easier. It allows us to speed up the design safety work. And Kent delivers industry-leading technical safety analysis. We do that for our peers, our clients, our partners. We have our own tooling in-house. We have our own computational fluid dynamics team. So we can rapidly do that safety analysis to make sure, knowing that hazard, we can keep everybody safe and undertake the actions in the project to make sure that we deliver as safe as possible. Around the brownfield and the balance of plant, we're very well versed in undertaking this type of work. For the car slab, we really like that approach. We need to make sure we've understood the geotechnical conditions. Typically we wouldn't need piling, but we would check in with our geotechnical experts, make sure that we got a good subgrade preparation to provide a suitable substrate paving. Need to think about underground services. If we can avoid them going underneath the slab, it can be very hard to get at them afterwards. So we would suggest using falls on that car slab to a perimeter channel drain. The solution spreads the loads, so it's a really nice solution for us. And for brownfield safety, we would of course check for buried services. We don't want to hit anything untoward. As you heard earlier in my segment, Kent started off as an electrical and instrumentation company. Electrical design is part of our business. We would do that in-house with our own electrical engineering team. And we've got dedicated teams for the brownfield integration. So things like the pipe work, cable controls, to make sure that we can safely connect the hydrogen to the user. And whilst that Ohmium solution is very cost efficient, we can make sure that the connections and the works arising meet the site standards and requirements, because there might be particular constraints from the customer, and we'll make sure that that's well looked after. So, Lina, if you could move the slide on, please. Lina mentioned around the development expenditure. There are very set ways of developing energy projects. Kent is very well used to running through those. But for new projects, that development expenditure is challenged. Previously, we've had government support to set up emerging markets in hydrogen. That support is being phased back. So a standard design and approach can significantly reduce that development time and effort. So we really like the approach that Ohmium have put forward. We've explored safety permits and consents. We were interested if we could get standard packs that would allow us to run through that permits and consenting process. But we're very much at the mercy of what's in the surrounding area and the impact of a new project on that. So what we understand we can do is generate a lot of material, standard documentation based on Ohmium's design, and that would make that process a lot more rapid because we can keep using that standard input over and over again. And the same for execution planning, having a predictable approach, a design that we already know, a clearly set out construction schedule allows us to make that predictable. And all that predictability makes it much easier for our clients to get their investment in place and move very rapidly through the project development phase to get into implementation. And the faster we get hydrogen deployed, the faster we get the decarbonisation that hydrogen allows, and the better we can perform for the environment. So if we go on to the next slide, please, Lina. So the Secretary General reminded us recently that the climate emergency is a race we're losing. but it is a race that we can win. Green hydrogen offers a sustainable and secure and homegrown energy in the form of hydrogen for lots of applications, for example, high temperature combustion. The challenge we understood from our customers is the widespread deployment needs that levelized cost as low as possible, and a clearer path to financial investment decision. Ohmium's solution, we can see, does that really well, and that's why we at Kent are very attracted to us, to this solution. So we're able to deliver highly competitive, lower levelized cost of hydrogen, a faster deployment, seamless integration, using methods that we well understand, that we've used widely through the energy industry for a long period of time, and using modularization and our safety systems, we can get a much safer and easier installation. So that overall approach allows us to get hydrogen to our customers as quickly as possible and get the benefits of that decarbonisation. So my thanks to Lina. Thank you very much for presenting with me, and thank you all for listening to us today. We'd be really interested if there are questions that we can engage with. Thank you. So
Thank you very much.
To you, Carlos.
Thank you, Matt, for your presentation, and thank you, Lina. So there are a few questions here at the Q&A box, and I encourage all of you who are watching us and the audience to send your questions. So I think let's actually start with the first question here, which is it says, how does energy density of the electrolyzer impact EPC costs?
Okay, maybe I can take that first. So if you have a higher energy density, it means with a lower footprint, you can produce more energy. So if you have an electrolyzer solution with a high energy density, that means that your footprint is lower. And that means that your civil costs are lower because you need less civil costs to actually build it. Your piping network, your mechanical components are also cheaper because you don't need your distances are reduced. Similarly to your cabling networks, your firefighting footprint, access roads. So the entire infrastructure becomes more compact and therefore more cost efficient. Matthew, if you want to add anything, just feel free.
Not on that one. I can see some other questions I can pick up on. There's one where it said, I mentioned the Spartan approach. That's correct.
Yes.
In fact, we were covering it in the office this morning. We had a lot of electrolytic hydrogen projects that we've been looking at for a while. And with the challenge for reducing the levelized cost of hydrogen, we were looking through projects to see all the different pieces that project didn't need to operate safely. So we were trying to strip down electrolytic hydrogen projects to as bare as possible. And that's why we really like Ohmium's approach. Ohmium has taken out buildings, it's taken out welfare, it's taken out control room, it's reduced the project to the bare minimum. And that has two effects. One, there is less things in that project, so there is less cost to install all of those things. But we were also challenged with the size of construction teams. There are a lot of people that go into construction teams as well as those delivering the construction. So the smaller and more simple we can make that approach, the less cost there is with that overall construction infrastructure. And again, with the duration, the smaller we can make that construction team cost. So this solution resonated with where we were going as Kent, and that's why there's a lot of interaction between ourselves and Ohmium. I hope that answers that okay.
Thank you, Matt. So if I understand it correctly, it's about just having the exact components that you need, right? And not more.
It's really easy to add lots of things to projects.
Right.
And we've seen that in lots of energy projects over the years. Electrolytic hydrogen is very cost dependent. And to succeed, our clients are requiring us to get that cost right down. So taking things out of a project, simplifying the approach, getting things done off site, they're all things that are helping that project. And we're really liking that.
Okay, thank you. And well, there is actually a question there that is about things that you require in the system, and one of them whether you require any buildings, weather protection, or HVAC. So, do you need any, or which of those things are required in the Ohmium?
Yeah, so if your plant is consistent of only the Ohmium solution and you do not require any additional balance of plant, then no, you do not need any building. You do not need HVAC. And the system can operate between temperatures of -45 to 50 degrees. But there's a cold weather package associated with sub-zero temperatures.
Thank you very much. They also asked whether it includes a control system.
Yes, so as I mentioned, we have one of those cabinets. It's called the telemetry cabinet, and it has a PLC. So it has a control system there where and you can use that to monitor your plant and control it.
Okay, great. Do you have here there are a few questions regarding the sizes that you could cover with these solutions. So what's the smallest size in megawatts and the largest size that you can cover with your Ohmium solution?
Oh, so the smallest size, so typically we don't really install anything that is below 1 stamp, which is 3.5 megawatts. So this is our smallest system size. And you can what is the biggest size? Well, it's up to the client, and it all depends on the limitations at the site. But the whole idea of modularity is that you can just place these islands next to each other, and you can go infinite in size. Yeah.
Okay, great. Let's see. There are also a couple of questions here. One of them is on the how long does it take to install your system? So, how long would it take to install a 100 megawatt plant? Is the question.
Yeah, that's a good question. We can do 100 megawatts. I believe it can be done in 2 months.
2 months. Okay,
Yeah.
that sounds
Yeah,
that
fast
is
because everything
very
is
fast
is
indeed.
there. Yeah, everything is there. All you have to do is just put it on site. It's similar to a battery energy storage system where
Mm,
it's plug and play.
okay. By the way, Matt, so if you want to jump in and say anything, please do.
I was waiting for Lina to finish. Again, we were really interested in this approach. So it's with the plug and play, it's trying to reduce on-site fabrication that we would have with a lot of our projects. So the pieces are all delivered to site, and it's put together without a lot of specialist construction equipment. So that makes it easier. I mentioned in terms of skilled trades and labour, we have a real pressure on the availability of skilled people within Northern Europe and the UK. So actually producing projects that reduces that load on site is going to enable us to do our energy transformation that much quicker at the same time as doing infrastructure and lots of other projects. So this is a good solution, a good approach. I saw from, is it David Cole? There was a question about standardized equipment and automated engineering design. We've not quite done it for this. We are doing lots of automated design in our offices. We're thinking through how we go through and reduce the amount of people that are working on projects for the same reason that at site there's a limit to the amount of professional and technical people. So in other areas we have automated around a lot of our initial process feasibility for green hydrogen. We have automated systems. We're not quite there to do it for this, but with a standardized and repeatable system, we employ coders to do exactly this. So yes, we would be very interested in doing that. So it's good thinking.
Thank you. So maybe we go to the next question. Inian Sivan Sankaram has a question on how you combined these pre-engineered, pre-designed models with the user requirements, right? So his question reads, since the modules are pre-engineered, how are the detailed engineering deliverables managed with respect to the end users' requirements?
Okay, so basically, with the it depends on what is the requirement, right? So if the client requires hydrogen at a specific pressure or requires hydrogen to be stored or requires a certain purity of hydrogen, so it depends on really the specifications of the output hydrogen that is required and the application of that. This is where the EPC contractor comes to complement that. But for the specifications of the Ohmium solution, you can produce hydrogen at 10 bar or 30 bar at a ppm at a purity of 4 to 5 4 nines or 5 nines. And obviously you have a certain oxygen content there. If you need it to be less, you need a deoxo. If you need the pressure at a higher pressure, you need an additional compressor. But having an output pressure starting at 10 bar or 30 bar reduces the number of trains that you require. So your overall compressor system will be smaller and cheaper than if you were to have an output pressure at a lower than 10 bar. Similarly, storage and all of the complex balance of plant. And this is why it's very important that an OEM works with an EPC to deliver a full solution to clients. And this is exactly why this department in Ohmium was established. The EPC management department is to work and partner with EPCs to deliver exactly that.
The question might also be asking around how the engineering deliverables are managed against the client's expectations. And this has been a challenge in that we're aiming to get the lowest levelized cost of hydrogen. But if there's then a whole set of bespoke requirements from a customer, there's a cost to doing all of that documentation to their requirements. So really happy to meet the client's requirements, but I think we all have to understand there's a cost and schedule to that. So our recommendation would be where we've got the interfaces and there's value in doing bespoke documentation. Yeah, absolutely, we can do that. Can we think about how we buy a bunch of other standard things, though we keep the same documentation to do do that with the electrolyzer system. So only make things bespoke where we really need it, and we all as a project need to pay for it.
Thank you very much. So it makes complete sense, if you want more bespoke things, it's gonna cost more. So there are a couple of questions on safety. So one of them is by Sadiq Sadiq, and they're asking, can you elaborate on the safety of this procedure more? What are the concrete risks and mitigating measures? And also, Jonathan Perez asks, from a QRI safety perspective, what distance can these be installed from the general public? Could they be installed in cities to prevent pumping or transportation issues? So over to you on the safety measures and safety margins you need to have with your systems.
Sure, sure. You know, if you compare hydrogen to natural gas, hydrogen has a very low ignition energy. It's around 0.02 megajoules versus gases are around 0.29. So it's a very flammable, very dangerous gas. And where hydrogen becomes a hazard in these kinds of in electrolysis is when hydrogen mixes with oxygen, yeah, or with an oxidizer. So you need to use best practices to mitigate those risks, like ventilation, detection of levels of hydrogen and oxygen, H2 detectors, things like that. In Ohmium, we have designed the system in a way that hydrogen does not mix with oxygen. Okay, and you have the compartments within the cabinet that create a safe environment for hydrogen to be vented. And where the stack is, you have a forced ventilation where it's continuously operating with redundancy in case one of the fans is by any chance defected. And the air circulation rate is extremely high, higher than what is required to achieve safe levels. So hydrogen is continuously vented, and at the same time you have sensors and hydrogen sensors where necessary. We can definitely walk you through the product safety features offline. You also have to make sure that in the case that something goes wrong, for example, both of your fans got damaged, no more forced ventilation, you're still monitoring your LEL levels. And there's a feature where this system safely shuts down below 25%, right? So we don't have, by the way, we don't have ATEX rated equipment because it's not required. And all of that is because of the way that the system is designed. And we can definitely talk more about that. So this is with respect to the hydrogen production unit.
Thank you very much, Lina. So Matt, please, what are your thoughts on this?
Lots of hydrogen projects have been caught out with their safety separation distances. So, but I'm sure lots of people on the call who are used to contracting and design of plants, our best friend is safety separation distances, putting people, sensitive things, well away from the risk arising from the hazard. So bear with me, I'm slightly reluctant to give a distance because it will depend on the number of electrolyzers and how congested that area is. I would defer to my in-house design safety team. We would do an early QRA for the design and the site and advise as quickly as possible what our analysis showed for those safety separation distances. It's a really good lesson from so many hydrogen projects. Get the early preliminary QRA in and get a good understanding of what those distances are and whether we need to do anything else for that project. And the other thing about safety is, again, like many people who are in the contracting or energy industry, we have well understood design safety processes. They're there for a good reason, to keep people safe. We would run through those and make sure that we deliver a safe design.
Thank you very much. I think it stands to reason as well that that there is no one size fits all answer, right? That you need to evaluate each case, and see what would be the safe distance for each use for each scenario. So there's a question here actually on the design life of the solution. So yeah, so how many years are we talking about?
Well, I mean, we've received requests for long-term service agreements for 10 years, 20 years, 30 years. And this kind of model is very typical in these kinds of projects where the OEM, you pay an annual fee, and the OEM takes care of the maintenance and is responsible for the lifetime of the equipment. Obviously, there needs to be a specification in the beginning for the lifetime of the civil works mostly, but under an LTSA, everything can be managed. For stacks in specific, they obviously have a lifetime, and but this is managed separately. Stacks degrade depending on how you operate them. So it depending on the operational profile, we can figure out what would be the stack lifetime and what are the replacements that are required along the life of the project over the duration of the project.
Thank you very much. We are, almost out of time. There are a few questions. Just wanted to let everyone know that we will actually send the questions to the speakers so they can answer offline as well. And I know there are questions on offshore electrolysis. There is one actually that maybe we can try to answer now, which is on the UPC structure. So bear with me. So it's by Saeed Moqtadi, and it reads, so the project is managed in an EPC structure, and I would like to know which party is responsible or which parties are responsible for the overall performance of the project. Licensed in brackets, maybe when licensed. So yeah, what's a typical arrangement there? How does it work?
I mean, the typical EPC structures out there, right? If it's a lump sum turnkey, then the EPC was responsible for perhaps the performance guarantees of the OEM. But typical structures we're seeing are split contract arrangements where the owner directly buys the equipment, and so the OEM is responsible for the performance of the hydrogen plant, but at the battery limits of the Ohmium solution, which is basically at 10 bar at 10 bar. So we guarantee a certain pressure with it at a certain purity, right? And we guarantee a certain degradation based on of the stacks based on the operational profile. And obviously everything that is obviously as long as the water quality is within the specification of the going inside the water treatment cabinet. So as long as the water quality is not compromised, because this impacts the stack life, then we fulfill our guarantees. Now we owe this is what we guarantee to the owner, and obviously the EPC will guarantee his portion of the works.
Thank you very much. I don't know, Matt, if you'd like to add anything to that.
Well, I can see we're nearly out of time. No, I'm happy with that response.
Okay, great. So thank you very much to everyone who joined today to watch this webinar and to interact with the speakers. And thank you, Lina and Matt, for your presentations. And well, I hope to see you here again soon. Thank you very much.
Thank you. Thank you
Thank you,
so much.
everyone.
Good day.
Thank you. Bye bye.